Hello, sir. My name is Nancy. Today I'm going to explain about object-oriented programming in Python. Introduction of OOPS concept. In Python, object-oriented programming is a programming paradigm that uses objects and classes in programming. It aims to implement real-world entities like inheritance, polymorphism, encapsulation, etc. in the programming. The main concept of OOPS is to bind the data and the functions that work on that together as a single unit so that no other part of the code can access this data. Main concepts of OOPS classes, object, polymorphism, data abstraction, encapsulation, inheritance. Block diagram of object-oriented programming. First class. A class is a collection of objects. A class contains the blueprint or the prototype from which the objects are being created. It is a logical entity that contains some attributes and methods. To understand the need for creating a class, let's consider an example. Let's say you want to track the number of dogs that may have different types of different type different attributes like breed, age, etc. If a list is used, the first element could be the dog's breed, while the second element could represent its age. Let's suppose there are 100 different dogs. Then how would you know which element is supposed to be which? What if you wanted to add other properties to these dogs? These lacks organization and it's the exact need for classes. Syntax of class. Object. The object is an entity that has a state and behavior associated with it. It may be any real world object like a mouse, keyboard, chair, table, pen, etc. Integers, strings, floating point numbers, even arrays and dictionaries are all objects. More specifically, any single integer or any single string is an object. The number 12 is an object. The string hello world is an object. A list is an object that can hold other objects and so on. You have been using objects all along and may not even realize it. An object consists of state, behavior, identity. First, state. It is represented by the attributes of an object. It also reflects the properties of an object. Next, behavior. It is represented by the methods of an object. It also reflects the response of an object to other objects. Identity. It gives a unique name to an object and enables one object to interact with other objects. Encapsulation. Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of wrapping data and the methods that work on data with one unit. It puts restrictions on accessing variables and methods directly and can prevent the accidental modification of data to prevent accidental change of objects. Variables can only be changed by an object's method. Those type of variable are known as private variables. A class is an example of encapsulation as it encapsulates all the data that is member, functions, variables, etc. Block diagram of encapsulation. Next is benefits of encapsulation. Encapsulation not only ensures better data flow but also protects the data from outside sources. The concept of encapsulation makes the code self-sufficient. It is very helpful in the implementation level as it prioritizes the how type questions, leaving behind the complexities. You should hide the data in the unit to make encapsulation easy and also to secure the database. Need for encapsulation in Python. The following reasons show why developers find the encapsulation handy and why the object-oriented concept is outclassing many programming languages. Encapsulation helps in achieving the well-defined interaction in every application. The object-oriented concept focuses on the reusability of code in Python. The applications can be securely maintained. It secures the flexibility of the code through a proper code organization. It promotes a smooth experience for the users without exposing any back-end complexities. It improves the readability of the code. Any changes in one part of the code will not disturb another. Encapsulation ensures data protection and avoids the access of the data accidentally. The protected data can be accessed with the methods discussed above. Encapsulation in Python is the data is hidden outside the object definition. It enables developers to develop user-friendly experience. This is also helpful in securing data from breaches as the code is highly secured and cannot be accessed by outside sources. Polymorphism. Polymorphism simply means having many forms. For example, we need to determine if the given species of birds fly or not. Using polymorphism, we can do this using a single function. Polymorphism means multiple forms. In Python, we can find the same operator or function taking multiple forms. It also useful in creating different classes, which will have class methods with the same name. The help that help in reusing a lot of code and decreases code complexity. Polymorphism, multiple forms. A word polymorphism is derived from the Greek word. Poly means many and morphism means forms. It means a single function name or method name can have multiple forms, and this fulfills the wish of avoiding code duplication in the implementation. Block diagram of multiple forms. Polymorphism with the class methods. Python uses two different class type in the same way. Here, you have to create a for loop that in it iterates through a tuple of objects. Next, you have to call the methods without being concerned about which class type each object is. We assume that these methods actually exist in each class. Polymorphism with inheritance. Polymorphism in which defines methods in the child class that have the same name as the methods in the parent class. In inheritance, the child class inherits the methods from the parent class. Also, it is possible to modify a method in child class. That is, that it has inherited from the parent class. This is mostly used in cases where the method inherited from the parent class doesn't it fit the child class. This process of re-implementing a method in the child class is known as method overriding. Here is an example that shows polymorphism with inheritance. Data abstraction. Abstraction is really powerful for making complex tasks and codes simpler when used in object oriented programming. It reduces the complexity for the user by making the relevant part accessible and usable, leaving the unnecessary code hidden. Also, there are times when we do not want to give out sensitive parts of our code implementation. And this is where data abstraction can also prove to be very functional. For, from a programmer's perspective, if we think about data abstraction, there is more to it than just hiding necessary information. One other way to think of abstraction is as synonymous with generalization. If, for instance, you wanted to create a program to multiply 8 times 7, you would not build an application to only multiply those two numbers. Instead, you had created a program capable of multiplying any two numbers. To put in another way, abstraction is a way of thinking about a function's specific use as separate from its more generalized purpose. Thinking this way lets you create flexible, scalable, and adaptable functions and programs. You will get a better understanding of data abstraction and its purposes by the end of this article. Data abstraction in Python can be achieved through creating abstract class and inheriting them later. Next, inheritance. Inheritance is the capability of one class to derive or inherit the properties from another class. The, the class that derives properties is called the derived class or base class. And the class from which the properties are being derived is called the base class or parent class. The benefits of inheritance are it represents real world relationships well. It provides the reusability of a code. We don't have to write the same code again and again. Also, it allows us to add more features to a class without modifying it. It is transitive in nature, which means that if class B inherits from another class A, then all the subclasses of B would automatically inherit from class A. Types of inheritance: single inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance, multiple inheritance. Firstly, single inheritance. Single inheritance enables a derived class to inherit properties from a single parent class, thus enabling code reusability and addition of new features to existing code. Here, class A is base class and class B is derived class. Hierarchical inheritance. Hierarchical inheritance when more than one derived classes are created from a single base class. This type of inheritance is called hierarchical inheritance. Here, shape is base class and rectangle, triangle, circle are the base classes. Next is hybrid inheritance. Hybrid inheritance consisting of multi type of inheritance is called hybrid inheritance. Example, link, brightness, class, school. The block diagram of hybrid inheritance. Next is multiple inheritance. When a class can be derived from more than one base classes, this type of inheritance is called multiple inheritance. In multiple inheritance, all the features of the base classes are inherited into the derived. Block diagram of multiple inheritance. Next, object-oriented terminologies. Class. Classes are a user-defined data type that is used to encapsulate data and associated functions together. It also helps in binding data together into a single unit. Next, data member. A variable or memory location name that holds value to does a specific task within a program. Next is instance variable, a variable that is defined inside a method of a class. Next, inheritance. It is the process of acquiring the properties of the class to another. That is, one class can acquire the properties of another. Next is function overloading. This technique is used to assign multiple tasks to a single function, and the tasks are performed based on the number of arguments or the type of argument the function has. Last one is operator overloading. It is the technique of assigning multiple functions or tasks to a particular operators. These are the object-oriented terminologies. Thank you, sir.